limit. The concept of limits are a cornerstone of calculus, providing a rigorous framework for understanding the behavior of functions and defining key concepts such as derivatives and integrals. By mastering the concept of limit, one can unlock the power of calculus and its applications in various fields of math, science, and engineering. So consider the equation y of x. The first step in determining the limit of this equation y of x as x tends to a is to substitute x equals to a into y. You are calculating the y coordinate corresponding with x values very close to a. The y of x referred to in this subsection will be a fraction where both the numerator and denominator will be power series in x that is of type this type. So number A, when the equation y of a leads to 0/0, it means that x equals a is a root for both the numerator and denominator, and you must therefore first factorize both parts and eliminate the common factor associated with this root. For example, calculate the limit of x to the power 2 minus 1 divided by x minus 1 as x tends to 1. This is the case. So you're going to have 1 to the power 2 minus 1 divided by 1 minus 1. So that will give you 0/0, which means that x equals 1 is a root and both the numerator and denominator have the common factor. So you can expand x squared minus 1 as x minus 1, x plus 1. So the denominator is x minus 1, so it can cancel with the numerator part, and you'll be left with x plus 1. The limit is therefore given by the limit of, so from the original, so we've expanded this and cancelled with this, so we'll have the limit of x plus 1 as x tends to 1, and this gives you 2. So looking at the MATLAB command, so you will type the first line, sims x. This line declares the variable x as a symbolic variable using the sims command. So this declaration, it allows MATLAB to treat x as a symbol rather than a specific numerical value. So we go to the second line, k of x equals x squared minus 1 divided by x minus 1. So in this line, a symbolic function that is k of x is defined. So it represents the mathematical function, which is our rational function. So we have a numerator of x squared minus 1, denominator x minus 1. This is quotient of the numerator and the denominator rational function. Third line. So in this line, the limit function in MATLAB is used to compute the limits of the function k of x as x approaches the value 1. So the result of the limit computation is assigned to the variable answer 1. So the syntax of the limit function is limit f a. So here f is the function and a is the value that x approaches. So this gives us 2. So let us look into number b. So when the limit of y of x as x tends to a very large number leads to infinity over infinity, look for the highest power term. It can either be x to the power n or x to the power n in this rational function. So divide both the numerator and the denominator with this highest power to enforce limits of this type and not of this one. So the reason is that 1 over x to the power a is equals to 0, and when x goes to a very large number, this is something we can work with, but this, if x approaches a very large number, it's something we can't work with. So for example, calculate the limits of this rational function. This is the case where we get infinity over infinity with highest power x to the power 2. So dividing above and below by x to the power 2, this is what we get. So you're going to say x squared divided by x squared minus 2x over x squared plus 5 over x squared 2 over x squared minus 3x squared over x squared, which is just this. So this divided by this give us 1. This divided by this 2 raised to the power minus 1, and this 5x raised to the power minus 2, and this would be our numerator. So take the limit. So we're gonna have 1. Okay, so remember, first term of the numerator is 1. The second term, so this will give us 0. Why? So we have 2 divided by a very large number, so this tends to 0. So you can try this out on your calculator. Maybe start with 2 divided by 10, increase 2 divided by 1,000, 2 divided by so you will notice that as you increase your denominator, it tends to 0. So same thing here, it's going to be 5 divided by a very large number. This tends to 0, so that's why we have 0. Same thing here with 2. So we have 3 here. So this gives us minus 1 over 3. So try this out on MATLAB, and you should get the same answer, minus 1 over 3. So number C, when y of a leads to division by 0, not the same as this. Try and simplify the expression first. For example, calculate the limit of 1 over this. So the limit is not of type 0 over 0 or infinity over infinity and is undefined, but after simplification of the denominator, the limit is given by this. Okay, so you will actually simplify. So this times this, you're gonna have 1 over 2, 3 times s minus 3s. So you have 1 divided by a half minus. So this will tend to 0, giving you 1 divided by 1 over 2, which is 1 times 2, giving you 2. Okay, so MATLAB should also give you the same answer.